Participants are requested to wait for 5 minutes. Let other participants to join. Good evening, everyone. It gives me great pleasure to welcome you all to this ATAL online faculty development program on cutting edge advances in artificial intelligence and data science. This FDP has been designed to enrich the knowledge of faculty members, researchers, and academicians with the latest breakthroughs and applications in AI and data science. It is my great pleasure to introduce our esteemed chief guest, Ms. Letty Vakumaturi, a highly accomplished educator and researcher. Ms. Letty currently serves as the head of computer science department at Dambi Dolo University, Ethiopia. She has published impactful research in artificial intelligence, contributed to academic books, and successfully completed several community projects. Her dedications to technological education is evident from the many workshops she has organized on app development, computer graphics, and web technologies. She is an inspiration to educators and learners alike, providing visionary leaderships in the field of computer science. On behalf of everyone present here, I take great pleasures in inviting our esteemed chief guest, Ms. Letty Vakumaturi, to address the gathering and share her valuable insights with us. Now, I'm going to hand over the sessions to our chief guest. Over to you, ma'am. Letty, ma'am. Uh, Ma'am, you can start the session now, ma'am. Ma'am, we are not hearing your voice, ma'am.
Hello.
Yes, ma'am. Now it is audible.
Okay, thank you very much. I made a mistake. Hello, everyone. My name is Lati Wakuma, and I'm from Demdol University. I'm currently working as the head of Department of Computer Science at Demdol University under the College of Engineering and Technology. Um, Before starting the training, I'd like to sincerely thank and appreciate the training coordinator who reached out to me, and the chairperson of the institution, and all the stakeholders who participated in organizing the training. So as the training mainly focused on the cutting edge advances in AI and data science. One of the topic given to me is data-driven machine learning. So in this session, we are going to discuss about the data-driven machine learning. So those are the outlines. We will start from introduction by discussing what means by the machine learning, even though you already know about the basic terms used in machine learning and in data driven, which focused on data. We will discuss about the data foundation, starting from the data source, and then we will jump to the data preparation and the processing, which comes after data collection, and then we will discuss the learning paradigms of data driven in machine learning. We will discuss one by one, and then we will discuss about the scalable and efficient data driven ML or machine learning. Then after that, we will discuss about the data-centric AI practices. So as you can see from the title of this session, it focuses on the data driven, right? There is machine learning, and it is about giving insightful explanation to the data driven. So here in this session, we are going to mainly focus in data driven, or in data, since it is the fuel to our engine when it comes to the machine learning and any other AI and trending technologies. Then we will learn application of data driven machine learning, and then we will discuss the future direction of data-driven machine learning. So we will start from the machine learning. What is machine learning? I know most of you know or familiar with this term. So as an introduction, we have to start from the base. That is why we are discussing or starting from the machine learning. So a machine learning is a subfield of AI which focused on developing algorithms and models, and those algorithms are used by machines and computers in order to give decision or perform any other tasks like humans do. So before having applications which can perform as a human, machine learning comes first, or we start from training our machine. So as a human, we can now read the slide, right? And you can ask me a question after this presentation that comes from listening. So this came from learning. We have learned how to read characters. We have learned how to listen carefully with shifting our focus, right? So this is how human learn it. So when we say machine learning, it is about giving the ability to make a decision and make a prediction like human. So that is what the machine learning stands for. It is about teaching the machine. There are basic components of machine learning. There is data, there is model, there is learning algorithm, and we have evaluation. So when we say data, so since we are going to discuss about the data in detail, to make it short, when we say data, it is an input to the model. So this data can be structured, it can be unstructured, it can be semi-structured, and it can be collected from primary source or secondary source, or we can use web crawler. So it depends, right? So that is what we call data. And the second one is the model. So for the model, it is about coming with mathematical or statistical representation of patterns in a data. So having the data doesn't mean your system can act or behave like human or make a prediction. So model is another thing which is used to represent the patterns in a data, or used to get the knowledge out of the data. Then there is other thing what we call the learning algorithm. So within the model, we have algorithm that used to adjust the model based on the data. So it creates a communication between the data and the model. Then the last one is evaluation. So let us say we have build an AI system which used to predict a sentence as a positive or negative, and after finishing, we cannot say the system can work successfully, right, without evaluating it first. So here the basic thing is it is creating a machine, right, that can predict like a human. So you cannot say I have built a system that can perfectly replace human or predict like human without first evaluating the system, so or evaluating the model. So here is where the evaluation comes in. So it's used to measure the accuracy and the performance of the model. So those are the basic components of machine learning. Then this is the relationship to data-driven approaches. So the traditional programming, and then we have the machine learning, right? So when we say traditional programming, we have rules, and we will take data, and the program will display the output, right? Let us say you are asked to write a program that calculates addition of two numbers, right? So the first thing you do is writing the program, which is the rule. You will declare a variable, and you will write a program that is used to ask an input from the user, right? So that is the instruction, the rule. And the data is, for instance, sorry, let us take the same example. So the question is writing a program that calculates addition of two numbers, right? So after writing the rules or the instruction, the program will give you the output if you provide the data. For instance, if the program is asking asking the user to insert two numbers, so that two numbers inserted by the programmer or by the user, it will be the data. So we have the program, we have the input, and then it will provide us the output. This is how the traditional programming works. And we are discussing about machine learning, right? So in machine learning, it is reverse. We have data, then we have output, and from the data and the output, we will get the rules or the model, and then instructions or the system will do the work depending on the rules or the models. So this is what the machine learning stands for, or this is how the machine learning is different from the traditional programming. Then let us see the examples. We have email spam filtering, right? So there is a spam folder in our email, right? So it collects the spam email that can trick us, or that are mostly scams. So this can be one of the example of a model or a system developed by using the machine learning. So you are mostly familiar with the recommendation system, for instance, on YouTube, Amazon, or Netflix. The recommendation system is there, right? For instance, if you watch comedy movies for 3 days in a row, then on the fourth day, the recommended videos will be comedy movies. So those are few examples of machine learning. So let us see traditional model-centric versus data-driven approaches. So we are about to start the main topic of this training, which is data-driven. So when we say model-centric, as the name suggests, it focuses on the model. So you deal with designing a better algorithms and the model architecture. So that will be the major focus in the model-centric approaches. So it is known as also classical machine learning. So there is one assumption, which is if we improve the model, the performance will improve. So we will give our attention to the model, building a good model, or coming up with a good algorithm. Then we can improve the performance, or we can build a system that can perform with 99 or 100 accuracy. That is the assumption. But it has its own limitation, right? Because if you don't have sufficient data, or your data is biased, then you can have a system which or a model which underperform. So that is what the model-centric approaches or classical machine learning standards for with this limitation. So to overcome this limitation, the method proposed is known as data-driven approach or modern AI. So this one prioritizes the quality, the diversity, and the scale of the data. So um, as the name suggests, it says data driven, right? So the focus is on the data. So you will give priority for quality of the data. You will work on how to have a qualified data, how to have a data that is free from bias. So that is what the data-driven approach or modern AI or data-driven machine learning works for. So this is how it works. So it is about giving priority to the quality, diversity, and the scale of the data. So it is also known as the modern AI. So you must have the high quality data, then sufficient scale in the appropriate model. So when we say data driven approach, it doesn't mean uh, um, shifting the attention only to the data and ignoring the model. It doesn't mean ignoring the model. You will choose appropriate model, and then you will use the high quality data. But your priority is not working on the model, improving the model. Your priority will be prioritizing the quality of your data. So this is the difference between model-centric and the data-driven approach. Then we have another thing to discuss in detail, since it says data-driven, right? Data-driven, and we have said that this data is an oil to our engine, so or fuel, right? So or we can say heart in case of humans. So let us see the data definition or foundation. So what is data? What is data? So when we say data, it is raw data or raw symbols and observation, or it is representation of information in measurable and recordable form. So data is not information. I guess you know that quite well, but it is a fact. When we say data, it is a fact that can be measured or recorded. So that is the definition we give for data. And the types of representation or the way the data or the fact is represented can vary, right? It can be represented with numbers, text, images, signals, or sensor readings. And the other confusing thing when it comes to data information and knowledge is, or confusing thing about the data is identifying the difference between data, information, and knowledge. So let us start from data. So when we say data, it is raw symbols, observation, and we have then information. So we say that data is a fact, then there is information, which is the processed data. With the processed data, we will have information, and when we use the information to take some action or to predict something, that is known as knowledge. Let me take one simple example. So there is student data, which is about their score in mathematics subject. So that will be the data, and if you generate information or if you process the data in order to identify students who score greater than 50%, that will be the information. And by using this information, so if you perform something which is 60% of the class scored greater than 50%, that means more than half of the students are attending the class successfully. So this is the knowledge. We have said something, or we have creating an insight by using the information. That is the knowledge. So let us discuss the types of data. I'll make this fast. There is a structured data, then we have semi-structured data, and we have unstructured data. So when we say structured data, if it is represented by using relational databases, by using the relational database, that means when we say relational database, we are talking about column and rows, right? So if the data is represented like this, it is known as structured data. So banking transaction, sensor measurement, tabular medical records can be structured data. And the second one is semi-structured data. This one is, it's a semi, right? It is partially structured. By looking at the data, you can retrieve some information, but it is not clearly stated. But you can get some information. For instance, the good example I would love to mention to my student is the XML, right? You know how the XML is written, right? The data in XML, tags will be used. So you can retrieve the information even though it is semi-structured, which is done by using the tags. And the analysis are, they can contain nested structure. It is most of the time a mixture of structured and unstructured info. So with the structured data, statistical models can be used, and ML algorithms such as decision trees and the linear regression can be easily used. In semi-structured, for semi-structured in AI, it needs parsing and normalization, because you know the reason, right? It is semi-structured. The other one is unstructured data. So for this one, there is no predefined schema. For semi-structured data, there is a predefined schema, but for the unstructured data, there is no predefined schema. It is raw, and the data can be heterogeneous. It can contain images, it can contain audios, videos, texts, or free-form documents. So this is how the data is represented. So if in case you have such like data, it is known as unstructured data. The challenge with unstructured data is it requires feature extraction, embeddings, or neural networks to process the data, because it is not structured. If I give you the example of those three data and ask you to select one of them, I'm quite sure you will select the structured data. So because it is predefined, everything is out there. It is easy to understand. It is clear. But for the unstructured data, you will require to do feature extraction and other techniques. The other one is temporal and sequential data. This one are data with time or order dependency. The examples can be stock prices, sensor signals, or ECG readings. One of the common example you are related when it comes to temporal or sequential data is voltage usage. So voltage, depending on the voltage usage, we will perform we will do the electric bills. We will pay the electric bills, right? So such kind data are temporal or sequential data because they are dependent of time and order. So when it comes to the voltage usage, here in Ethiopia, it will be done per month. So, it is time dependent, or it will done in order. So such like data are known as temporal and sequential data. The other data are spatial or geospatial data. Then we have streaming or real-time data. Those two can be those three can be classified in unstructured data. So when we say spatial or geospatial data, if the data is tied to location, for instance, for GPS data is about the location, right? So such like data are known as spatial or geospatial data. The other thing is streaming or real-time data. This one is, it says stream, right? Or real-time. So this one is continuous flow of data, and it is often high velocity. it is real time, which goes with the time. As the time goes up, then the data will go up. So it is dependent of the time. So this is known as streaming or real time data. Um, so basic thing is you need to know about data in modern AI system, and data driven machine learning is the first one. Is, we have said this, oil or fuel, right? Data is used as the um, fuel of AI. So if you have good quality data, or a data free from bias, then you will most probably have a good model. So data is the fuel. So AI or machine learning systems are dependent of data. The second one is, bigger is not always better. This one is about shifting the focus to the data quality, cleanliness, representatives, and fairness. So, uh, in specifically in deep learning, if you have large volume data, then your system will most probably predict better. So, what we are trying to say is, um, the performance of your system do not rely on the volume alone. So, of course, having large volume data is great, or it is good, but bigger is not always better. If you lose the data quality or cleanliness, then you will not have a good performing AI model. Then the other thing is generalization and bias, which is related with data quality and the cleanliness. The other thing is feedback loops. So you need to collect the feedback on your system, or you need to collect the data, and that feedback will used to improve your system. And the shift in research and in industry, when it comes to the data-driven machine learning, is in early AI, there was algorithm innovation, or the focus was about the algorithm innovation. But in the modern, just the focus will be to the data engineering and the related tasks. So we will discuss this in detail later. So let us simply overview. Real world motivation and the examples of data driven models are in healthcare, in autonomous vehicles, in e-commerce and personalization. We have discussed about the personalization. Recommendation of videos and the TV channels can be about the personalization. It is about giving recommendation uh, depending on your personal interest, right? Then in finance, in the fraud detection, and in natural language and the processing, though data-driven machine learning can be used. So the other thing is about the data sources and acquisition. Data sources and acquisition. So I have tried to mention few of them. The first one is primary data. When you say primary data, those are collected firsthand via experiments, survey, and sensors, and they have high reliability because you will collect them through experiments or maybe by yourself. And when we say secondary data, it is about using existing data or researches. So for those two types of data source, let me give you one simple example. Um, uh, let us say I asked you to give me information about number of students join your university every year. So when you say primary data, you will go to your university, and then we will ask every department the number of students join every year for 2 or 3 years. That is primary data. You are directly contacting the stakeholders in order to get the information. That is the primary data. And when it comes to the secondary data, just you will view your university's websites to get some insightful information. That is the secondary data. The other thing is synthetic data. This one is usually generated by the AI models. They are not original data, but they are fake data, but they can be used. We will discuss this in detail later. Then the other thing is web and the IoT sources. So information retrieved by using IoT sensors or by using web scraping or web spiders can be classified under the web and IoT sources. So let us discuss the other data foundation. So we have discussed about their source. Let us discuss about the data collection and the acquisition. So the data collection is the process of gathering raw information required for training, validating, and testing machine learning models. So the process of gathering information you need to uh, build your model or AI system or machine learning based system. That process of gathering information is what we call the data collection and acquisition. So as a method, you can use active collection, passive collection, or synthetic data generation. Those are actually related or another name given for the data source types. If you collect the data through experiments, surveys, or controlled environments, then the type of data collection is known as active collection. So rather than doing experiments or surveys, if you use some interaction or logs from websites, then this is known as passive collection. Then synthetic is this above generating artificial data. So either the data source is primary or secondary or synthetic. There are a variety of sources. You can get your data from sensors. You can get your data from application program interfaces. You can get your data from web data. You can use user-generated data, which is social media posts or reviews or ratings, and using open data sets is also another option to use for your sources. So, in addition to this, you can prepare questionnaires and observe the working environment of the system you are going to develop. So those can be the data sources. The other thing related to the data foundation is, so you have collected your data, right? You have collected your data from the sources, either it is sensor or user feedbacks. Then the next thing comes in your mind will be data storage, and it is management, where the data is going to be stored, how it is going to be stored, and how good can we manage the data. So as the data storage, you can use the relational SQL or non-relational databases. So if your data is have predefined schema and can be displayed or discussed with the tables, then using relational SQL will be great. And for non-relational SQL, if your data type is unstructured or semi-structured, then it is non-relational SQL, or using non-relational SQL will be great. And then the other thing is data warehouses. This one is centralized system. Then there is data lakes, which is used to store raw data. One of the good examples, I guess you have learned before or read before, is Hadoop. So it is one of the examples for the data lakes. The other thing is about the data management. So when it comes to the management, your concerns should have to be how you deal with the scalability, how you deal with the data governance, which is about giving access to the data, about the compliance, which is about the set of rules used across the countries, then the auditing, and then about overcoming data loss of course, the data loss can happen, right? We might delete data out of our smartphone, right? So one of the best way to overcome such like data loss is having backup and recovery, then metadata management, or developing a technique and a method for metadata or preparing metadata is also another concern is under the management. So if you know how to deal with the scalability of your storage, either by distributing the storage or enabling the devices to process parallelly, you have to be concerned about that, about how to give the access, about having backup and preparing metadata. So those are the management concerns. So your data quality can be uh, changed or can face data quality issues such as incompleteness, noise, imbalance, and bias. So we've said that in data-driven machine learning, it is about focusing on the data alone. Just it is not about ignoring the models, of course, but it is about shifting your focus to the data. So if you have incomplete data, or your data contains noise, or you have imbalanced data when it comes to the classification or bias, then that means you are having a big trouble, because data is your fuel, right? So in case of incompleteness, you can use mean regression based or dropping incomplete rows. This one is for the incompleteness. And if you encounter noises in your data, you can use filtering or smoothing. Actually, these techniques depend on the data type. For numeric data, for real-time data, for text data or image or videos, you will use different methods. So we are discussing this as a general. And if you have imbalanced data, let us say your data set contains two classes, positive and negative, that can be to a certain disease or for a sentence type or a sentiment type. So if you have 17, let us say your data set contains 100 rows. From 100 rows, 17 rows are positive and 30 are negative. So this is what we call the imbalanced data. So if you try to use one of the machine learning algorithm to make a prediction, most probably it will fall to the positive class. So this is what we call the overfitting. It learns too much to the positive one, since it contains 70% of the data. So for this one, using smooth, using undersampling or oversampling will be great. The other thing is the bias. These ones are systematic errors flowed from sampling or correlation. For this one, having fairness auditing of the data will be great, or the solution I will choose will be the fairness auditing. Working on the auditing of the data will be great. So the other thing is redundancy, duplicates. If you have duplicated data, then you will face overfitting, right? So outliers, temporal rifts, those can be other issues you can face in keeping quality of your data. So for instance, changes in data distribution over time can be one issue you face when it comes to the quality of your data. The solution will be continuous model retraining. The other thing is the data labeling and the annotation techniques. The data labeling and annotation can be manual labeling, crowdsourcing, or programmatic. So before discussing the three types of the models, let me differentiate the labeling and the annotation. So when we say data labeling, it is the process of tagging the raw data or the raw information. If you tag the raw data or information, for instance, let us say you have pictures of cat, dog, and cows, right? You have three categories or three classes. So if you label cat picture as cat, or if you name the cat picture as cat, that is what we call the data labeling. And when it comes to the data annotation, we have labeling, and there is a description or context or metadata to the labeling. So it contains labeling plus detailed information. That is what we call the annotation. So one of the three types of data labeling in the annotation is manual labeling. This one is when human experts annotate data. So the previous example we take in labeling pictures as cat, dog, and cows will be manual labeling, because we are making the labeling by ourselves. The other thing is crowdsourcing. This one is distributing the labeling to the labeling tasks to workers online. So it will be distributed. The task will be distributed. And the last one is programmatic or weak supervision. This one is automated heuristic distance supervision or rule-based labeling. So you will create a rule, and it will be labeled according to that rule by giving a weak supervision over the annotation. Then those are the data labeling and the other data labeling and annotation techniques. For there is semi-supervised labeling. So in semi-supervised labeling, there is a small labeled data set. Then the model will train or by using the labeled data set, and it will make the prediction by using a labeled data set. That means it says small, right? Let us say you have 1,000 picture of cats and dogs. Then you will select 100, or 100 pictures will be selected, and these 100 selected pictures have 50 cats and dogs labeled data, and the other 900 data will be labeled depending on this small labeled data set. So this is what we call the semi-supervised learning. The second one is active learning. In active learning, model is trained on a small labeled data set. Then it looks at the unlabeled data sets and selects the most difficult data to label. So that data will be annotated by humans, and then the machine will label the other unlabeled data. Let me repeat this one again. The model is first trained on a small labeled data set. Then it will select the most uncertain data from the unlabeled data, and that data will be given to human. The human will label and annotate the data, and then the model will predict the other unlabeled data set, or sorry, label the unlabeled data set. The other one is automated annotation. Automated annotation is leveraging pre-trained models to generate initial labels. This one is, as the name suggested, it is automated. So pre-trained models will used to generate the initial labels. So in data labeling and annotation techniques, we have to follow a method that is used to control the quality of the data. We have to make sure the quality of the data is kept. So this can be done by creating a clear labeling guidelines, using multiple annotators, or preparing agreement matrix that is used to label and annotate the data. So this is about the data foundation. Let us discuss about the data preparation and processing. Actually, what we have discussed about the annotation and the labeling can be classified under the data preparation and the processing. This subtitle is used to make those phases more clear and bold. So data preparation and the processing starts from data cleaning and processing. So when we say data cleaning, it is about transforming the raw collected data from different sources and make it suitable for machine learning models or algorithms. Just it is about shifting the format of the data to more understandable machine learning form. That is what we call the data cleaning and pre-processing. So the key steps taken can be missing value handling, noise removal, and the outlier handling, normalization, and the standardization. So those are key steps. And as I've mentioned before, the steps taken in data cleaning and the pre-processing differs from one data format to the other. For instance, for numerical data, we can use the mean, median, or mode or predictive models, and for texts, we can use other methods such as word embedding. So the step is taken different from one data format to the other data format, but the mandatory thing you need to know, regardless of the data type, is there should be a method to handle the missing value, a method to remove the noises. Removing the noises can be maybe when it comes to the natural language, maybe removing the stop words can be useful. Then the other thing is normalization and standardization. So even though it differs from one data to data, just you have to make sure you have done the key steps in cleaning and pre-processing the data. And data cleaning and processing, as we have said, it can differ from one data to the other data. For instance, for the categorical variable encoding, when we say categorical, it is when you have categories for your dependent feature, right? In machine learning or in your data set, you have independent data or independent feature and the dependent feature, right? So if your dependent feature is categorical, that means, for instance, we have said that positive and the negative. This one is categorical. So one of the basic thing you can do in data cleaning and the processing is changing the non-numeric, which is positive and the negative, to 1 and 0. That is what we call the categorical variable encoding. For this purpose, you can use one-hot encoding, label encoding, target encoding. Those are different types of encoding, and all of them have their own pros and cons. The other thing is for text and the NLP pre-processing, actually the categorical variable encoding can be applied to the text and the NLP pre-processing. Those are tokenization, then steaming, stop word removal. For instance, she is beautiful. She is beautiful. This is a sentence, and maybe you can categorize this she as a stop word, and then you can remove this. This one can be, or most probably, useful in improving your data quality and its performance. So lower casing, tokenization can be done in data cleaning and the pre-processing, and for time series feature processing, extract temporal features like day, month, season, or rolling statistics can be useful. So this is about the data cleaning and the processing. The second thing comes after data cleaning and the pre-processing is feature engineering in data-driven AI. So when you say future engineering, it is about adding a domain knowledge, transformation, or automated techniques to the pre-processed data. It is about transforming the data in order to get some insightful knowledge. So that is what we call the future engineering. So you can you can involve creating, transforming, or selecting input features or removing few features. This is feature engineering. Preparing the data is it is part of the data cleaning and the pre-processing. For this one, you will mainly focus on transforming your data. It is about dealing with the features. See, if you have 15 independent features, then maybe decreasing the number of feature can be part of the feature engineering. So there are different method of doing this feature engineering. The first one is manual feature engineering. So for manual feature engineering, features are designed using domain knowledge and the intuition about the problems. This one can include mathematical transformation. For instance, let us say you have height and the weight, two independent features. So you decided to combine the height and the weight in order to get the BMI of that person, and this BMI can be used for the health analytics. So this is mathematical transformation. You will make the decision. The other thing is aggregation, or generating the summary from your data, using the summary of your data. This is another method you use in feature engineering. Then the other thing is temporal features. This one is extracting features from the provided independent features. So this is the temporal features. The other thing is reverse of manual feature engineering is automated feature engineering. It says automated, right? So that means you don't need to waste your time by building the feature, or by selecting or excluding the feature. Those will be done by using different models and AI tools. So it can be feature synthesis. This one combine basic features through mathematical or logical operation. There can be model-based feature creation, embedding-based feature engineering when it comes to the neural networks. So those are the few things about the automated feature engineering. If you are asked to discuss the advantage and the disadvantage of both automated and manual feature engineering, is when it comes to the manual feature engineering. For manual feature engineering, it is time wasting, right? You need to study about the feature, since it is done manually, since it is your responsibility. And when it comes to the automated feature engineering, you can save your time, because you are going to call out some algorithm, and those algorithms will do the tasks. And it scales efficiently with large data sets. The other thing, and my favorite advantage of automated feature engineering, is it can uncover non-obvious or high-dimensional interaction, which is tough to identify for humans. So that is the huge advantage we can get by using automated feature engineering. Then, as a challenges, it is less interpretable than manual features. The other thing is it requires careful validation to avoid irrelevant or redundant features. Since it is done by algorithms, you have to make sure you validated every task is performed in this feature engineering. Then feature engineering in data-driven AI. This one is a feature selection related to the steps that needs to be taken in data-driven AI. So the first one is, after generating features, manual or automated, there is what we call the feature selection. So this feature selection ensures only informative and mandatory features are selected. So this is what we call the feature selection. It is about shifting the focus to only informative um, features. The techniques used can be sorry, statistical tests, model-based selection, or dimensionality reduction. Those can be used in feature selection. So, role of feature selection in data-driven AI is the first one is the quality and relevance of features often outweigh model complexity. Since the feature selection give more quality to our data, they can be great to come up with a good model. Then the other thing is automated feature engineering and representation learning are essential for handling high dimensional or large scale data sets. So for performing feature selection for on images or videos which are high uh, dimensional will be great with the automated feature engineering. It will be tough to use manual feature engineering. So feature engineering drives better generalization, faster convergence in training, improved performance as a general. So one of the things we have learned in feature selection, in selecting the feature, let us say, um, in order to predict the fertility of a soil fertility, you have more than 15 features that can be about the water content, about the other features. I'm not familiar with soil fertility. I cannot mention all the features though. Um, so you can have 50 of them. You can have 50 of them that one studies about the water content, about the phosphorus content, and the other ingredients that are mandatory for predicting either the soil is fertile or not. So when we say feature selection, from those 15 features, it is about selecting few of them that are mandatory in order to predict the soil fertility, right? So one of the methods used in feature selection is dimensionality reduction. So this one is reducing the number of features while retaining essential information, and there are few techniques you can use. The first one is known as principal component analysis. So for this one, I'll give you one simple example. Let us say you have a data of a score of students, and the score of a student is for three subjects: math or mathematics, physics, and chemistry. And from your data, students who score good in mathematics will score good in physics. That means mathematics and physics data are correlated. So in such cases, this principal component analysis will combine these three features for mathematics, physics, and chemistry into two or one by looking at the correlation of this data. So this is the method we call principal component analysis. The other one is t-distributed stochastic neighbor embedding. This one is mostly used for visualization. When we say visualization, it is for image and video-based data. So this one will decrease the dimension. For instance, you have image of craters, which is explained by using high dimension. That high dimension picture will be converted to three dimension or two dimension. That is done by the t-distributed stochastic neighbor embedding. It is about converting the high dimensional data to 2D or 3D. The other thing is autoencoder. Autoencoder is type of neural network used to learn efficient representation of data. So the method used in auto encoders is it compresses data into a smaller representation, or it will be encoded to a small representation, and then after encoding it will be decoded, then it will be reconstructed. So this about encoding and the decoding in order to deal with the size of your data. That is what we call auto encoders. So benefits in data driven ML is dimensity. This what the benefit is for dimensity reduction. The first one is speeds up training, then reduces noise and the redundancy. Then the other thing is facilitates visualization and interpretability. So those are advantages you can get from the dimensity reduction. Then the other thing is representation learning. So representation learning is a technique in machine learning where model automatically discovers the best features. It is a technique in machine learning where model automatically discovers the best feature. This is what we call representation learning. The techniques can involve embeddings. You know, embeddings. One of the example of embeddings is word embeddings or word to vec. You know this in natural language processing. Then we have latent features. So when we say embeddings, it is continuous. Okay, we will answer the question later. One of the one of the method done in embedding is it is about continuous having continuous vector representation. So to answer the previous question, in order to reduce noise in images, in order to reduce noise in images, there are certain techniques you can use that can be calling out different algorithms. So what we are currently discussing is it is not about the actually about the noise elimination or noise reduction. We are dealing with about the data representation. So what we have said here in distributed stochastic neighbor embedding is it is about dealing with feature selection. It is for the feature selection, right? So after feature selection, maybe after finishing those concepts, we can discuss in detail, even though it is not part of the presentation. The other thing that can be used in data-driven machine learning is data augmentation and synthetic data generation. So if most of you are interested in image and video-based data or computer vision, you know, this data augmentation, because mostly we use data augmentation in computer vision, right? So both data augmentation and the synthetic data generation are techniques that used to expand our data set size. So let us start from the data augmentation techniques. Actually, I will ask one quick question and invite you to answer it within 30 seconds. So what is the purpose of data augmentation? I will give you a choice. A, to overcome overfitting. B, to overcome underfitting. If you are a little bit related with machine learning, you know the answer. So you will answer this later. Then data augmentation techniques are mostly used in images. So you will rotate the images and used as a new data or flip or cropping. Those are techniques used to augment the data or expand your data set. For instance, you have 15 images of a cat, 15 images of a cat. Then and then you realize that 15 data 15 images of these cuts are not enough in order to train your data. Then you will decide to use data augmentation. That means you will rotate the images, five images from 15 original images. Then you will add to it. Then that means you will have another 5 new data. It can be used in text. It can be used for time series or tabular data, even though the technique is different. Then the other thing is synthetic data generation. I have said a little bit about the synthetic data generation. It is about using data that are artificial and generated by AI model and algorithms. Those are known as synthetic data generation. So they are part of the data augmentation. The other thing is simulation-based generation. The other thing is simulation-based generation. This one is using synthetic data, but that synthetic data will be simulated to real-world scenarios. That is what we call the simulation-based generation. We have synthetic data plus simulation. And the advantage or benefits will be reducing overfitting on small data sets, improving robustness, allowing experimentation. The other thing is data-driven learning paradigms. So we have a few minutes, so I will make this fast. Data-driven learning paradigms are classified into supervised, unsupervised, semi-supervised, and self-supervised. Those transfer learning and the domain adaptation can be classified in under one of them. Let us make fast and discuss about those data-driven learning paradigms. So when we say supervised learning, we have discussed this, I think, in the previous slides. You have labeled data, and these labeled data contain the input and the correct output. For sentiment analysis, you will prepare your data that contains labeled sentences as positive and negative, and you will train your machine using that labeled data. That is known as supervised learning. And the characteristics is it requires large labeled data sets. So since every data need to be labeled, it can be time consuming and expensive. The second one is unsupervised learning. The second one is unsupervised learning. For unsupervised learning, it says unsupervised, right? When you provide labeled data to your machine, that means you are supervising the machine. You are helping the machine to learn. But in unsupervised learning, there is no labeled data provided. The machine will learn from unlabeled data. This is used in clustering and can be used in anomaly detection. So since there is no ground truth set for the machine, evaluation can be harder. The other thing is semi-supervised learning. For semi-supervised learning, you have a small amount of labeled data and a large amount of unlabeled data. It says semi-supervised, right? It is combination of labeled data and unlabeled data, and it reduces labeling cost while improving the accuracy. The other thing is self-supervised learning. This one is a modern paradigm where models generate their own labels from raw data using pretext tasks. For instance, in natural language processing, predicting missing words in sentence can be one application of self-supervised learning. So it is field breakthroughs in LLM, large language models, and foundation models. Self-supervised learning is mandatory in natural language processing. Then the other thing is transfer learning and domain adaptation. As the name suggested, transfer learning is it is about using knowledge from one domain or task to improve performance on another. For instance, here in Ethiopia we have dam, right? So if if the engineers that participate in building the dam are asked to build dam in India, that means there is a knowledge sharing, right? So they are transferring the knowledge they used in building Ethiopian dam to Indian dam. So that is what we call the transfer learning. The second one is domain adaptation. This one is a special case of learning. It is about it is about adapting models from one data distribution to the another. One of a good example mentioned is, for instance, speech recognition. Uh, uh, for speech recognition of Indian English, you will use a model trained on American English. This one is model adaptation. You are adapting the model. So as a benefit, they both can save training costs because you are using uh, used knowledge and or you are using uh, build model. So those are other learning types. So in data driven, there is what we call scalable and efficient data driven. So scalable data driven machine learning refers to the methods and systems that can efficiently process large volumes of data to train models without sacrificing the performance. When you say scalable data-driven machine learning, it refers to the matrix and then plus the system that is used to process large amounts of data. So the challenges you can face in having scalable data-driven machine learning is high dimensional data, or you can have limited memory and the computational resources, or there can be long training times. So if you have large volumes of data, then you need to deal with the high dimension or high volume of the data. Then you have to deal with the memory because you can be out of resources, right? And if you have large volumes of data, that means it will take um, long training times. So those are the solution. Having GPUs for long training times, and making sure you have a good quality resources are solutions you can have. Then let us discuss about the big data and the distributed in machine learning, because we are discussing about the data driven, right? So distributed machine learning is a framework where training is split across multiple machine to handle uh, sorry um, distributed ML is framework where training is split across multiple machines. It says distributed, right? It said distributed. So your big data set will be distributed over multiple machines. That is what we call the distributed ML. It is a framework. So the key techniques that can be used is data parallelism, model parallelism, parameter servers, or gradient aggregation. So those are the key techniques. Those are the key techniques. Then as a framework, Apache Spark machine learning library can be used. So this one is great if you have a large volume of data and that is tough to handle by using a single device, or if you have billions of data. Then online and the incremental learning is another data type you can have in data-driven machine learning. So when you say online or incremental learning, it is designed for situation where data arrives continuously over time. So in online or incremental learning is right in continuously. So that is a kind of data we can have. Um so in traditional batch learning, it retrains models from scratch. So that means whenever a new data arrives or added to the already trained data, the model will retrain the data. But when it comes to the incremental learning, models or models that you deal with incremental data, the model iteratively executed or updated with each new data point. So the key feature in online and the incremental learning is memory efficiency, adaptability, real-time prediction. So those are key features of online incremental learning. The challenge is you have to make sure your model doesn't forget the old knowledge. So what we have said here is the model learn iteratively, right? Iteratively learns and the update is knowledge. So the challenge you can face is your model can't forget the old knowledge. So you have to make sure your model doesn't forget the old knowledge. Then managing noisy or inconsistent streaming data. So you have to use the right method or and the techniques, because unlike the traditional one data are fed into your models on stream. So you have to develop those methods. That's the example for online and incremental learning can be online versions of decision trees, incremental clustering algorithm. The other thing is federated learning. So for distributed learning, it is about having multiple machines, right? So those multiple machine will parallelly trained with a data. And in federated learning, it is a collaborative still it is a collaborative machine learning paradigm. That means there will be multiple devices used by a different organization, and each organization will train that model by using local knowledge, by using their raw data without exchanging or without giving out to the another organization. This one is a great way of preserving privacy in data collaboration or in big data. So the key feature is there is decentralization, there is privacy preserving. That means, let us say there are two institutions that use the federating learning. That is about the prediction of malaria. Let us take this example. Then one hospital in Ethiopia will train the model by using its own data from the patients in the hospital, and the other hospital in India will use its own data collected from the local patients. So that means there is a privacy preserving. The informations are private. They are used only by the hospital. The other example we are familiar with is mobile keywords like Gboard. It is used to improve predictive text using on-device learning. So for instance, if I okay, to take a simple example, the way our keyboard, our smartphone keyboard predict a text is by depending on the way we use, right? It depends on how we often use that term. Gboard or the mobile keyboard improves by taking the data from me. So that is one simple example. Then the challenges can be communication overhead, which means having frequent translation, alerts, right? So if there is a new patient Okay, sorry for the interruption. So let us go to where we stopped. I think now my voice is audible, right?
Madam, your mic is muted.
No, it is not muted. Is it?
Ah, yes, ma'am, it's now audible.
Okay, okay. So we have discussed about the challenges in federated learning. I think I have less than 5 minutes. So the other thing is we have already discussed about this one. I am making them bold yeah, in order to make them more clear, and they are pretty mandatory and important in data-driven machine learning. So we have discussed about this active learning. Then what we have said is that there will be a labeled data, and then the model selected the most informative or uncertain samples, and then it will request humans, and the data will be labeled by the humans. So so that the machine can predict well all the other unlabeled data. We have discussed about this one already. So those are the applications. It can be used in medical imaging, natural language processing, autonomous driving. The other thing is the most basic thing I want to discuss in this session is data-centric versus model-centric development. Data-centric versus model-centric development. So data-centric and model-centric are their difference is it is after the development of data-centric. That means in the early years of machine learning, most progress come from designing better models, deeper neural networks, more efficient algorithms, or smarter optimization methods. So the focus is on the model, but in recent years, the data scientists shift their focus to the data. So that is where the data-centric paradigm is proposed. So let us see one by one. So when we say model-centric development, so we have tried to mention a little thing about the model-centric development. The focus is it is about improving the algorithms in the architecture. So, for instance, if you train your machine, if you train your machine using CNN, then you will add layers to your neural network. So this is the way model-centric development works. So the limitation is by having a big model changes, by calling out most complex and most known models, you might not improve your performance of your data, because even though you came up with a good model, it still depends on the data, right? In machine learning, in AI, deep learning, the basic thing or the mandatory thing is about the quality of your data. The other thing is about the data-centric development. So here the focus is improving the quality, the diversity, and the consistency of the data rather than just the model. You will give focus to improving your data's quality. In this one, the practices you can do is you will balance your data set. You will use data augmentation. So I have asked you one question. right? When we learned about the data augmentation. What is the purpose of data augmentation? Is it about overcoming underfitting or overfitting? Is there anyone who can answer? So the purpose of having data augmentation in the data-centric development is overcoming overfitting. So this is another practices you can use in order to increase the quality of your data, doing error analysis, then continuous data iteration. That means updating and cleaning your data sets as your models are deployed. So most probably your models generalize better across unseen data because you have a good quality data, and it is pretty important in reducing overfitting to noise. So what we have discussed, or our focus were data-centric AI, right? We have model-centric AI and data-centric AI. For the model centric, we have algorithm and architecture improvement. We will give focus to the architecture, and we will consider the data as it is good enough. That is model centric AI. And in data centric AI, we will give focus to the data quality, and we will consider the models as they are good enough. And the performance driver will be bigger and the better models in model-centric AI. And in the data-centric AI, it is about having cleaner and more representative data. And as example, switching from CNN to RaceNet, or even adding layers to your CNN model is it is when you use model centric, because you are improving your model and you are working on the algorithm. But if you try to augment your data, try to balance your classes, and work continuously on your data to improve the performance, then that means you are following the data-centric AI, or you can say machine learning. Then improving data quality versus model complexity. So those are the other things we need to discuss. Model complexity approach means it is about applying complex models by adding layers, parameters, or new architectures to your already trained model. That is what we call the model complexity approach. By adding layers, by adding parameters, by adding new architectures, you are making the model more complex. So that is the model complexity approach. So it can be good or bad. It depends, right? One of the advantage or the pro of this model is by adding more layers, maybe you can get inside information from your data, right? And the cons is by adding complexity, you can lower the performance of your system, or even though the model is complex, still it depends on your data's quality. So as a benefit, it can capture complex nonlinear patterns. It can often improves benchmarks or large data sets. It can enable breakthrough like GPT and BERT. The other thing is improving data quality approach. So we have discussed about things we can do in order to improve the data quality, right? So in improving data quality approach, you have to make sure you have applied all those techniques. You have cleaned by removing duplicates. You have used data augmentation for expanding your data sets and balance your classes. Labeling by consistently labeling your data. So those are methods used in improving your data quality. It is benefits can be better generalization on unseen data, more fairness and reliability in real world settings. So when you use or when you focus on your data quality, that means you are giving more focus to the real world settings, because those data are gathered from real world scenario, right? So you are giving focus to real world scenarios or environments. And when you give priority for the model or making it complex, you are giving focus to machine, right? So to come up with a good model, the obvious answer will be the understanding the real world scenarios, because the main thing about having machine learning and all other trending technology is it is about making them act, behave, or make decision like humans, right? So if you give focus to the information or how the information is processed in the real world scenario, then your machine will easily understand. So that is why we are learning about the data driven machine learning. Then the modern view is balancing both. We have discussed about the model complexity or model centric, and we have learned about the data centric, right? So for the modern view, the modern view is balancing both. You will have data quality. Sorry, you will have qualified data. You will work on your data, and then you will use effective models. So by combining those two things, you can end up with best results. So as your trainer, I will recommend you all to use. Okay, sorry. Okay, may I stop? So the modern view is the balancing both. I think my time is up. Can the coordinator give me some sign on the time usage? Shall I continue? Shall I continue?
Ma'am,
Yes.
session 2 will start at 7:30 Indian time,
Okay.
ma'am.
Okay.
Yes, ma'am. Accordingly, we can manage and complete.
So
Yes,
I
ma'am.
have yes, I have 20 minutes left.
No, ma'am. Your Indian time 7:30, ma'am. Up to
Okay.
7:30 you
Okay.
have to present, and we are
Okay.
we'll be going to start session 2. So accordingly, you
Okay.
can manage, ma'am. Thank you, ma'am.
Okay, thank you very much. So if there is anyone with question, you can ask, and there is this material shared with the coordinator. You can take from the coordinator, and if you have any query regarding our today's session, you can contact me by this email. It is so glad to have you all. Thank you very much.
Thank you, ma'am. It's now right time to give vote of thanks to Letty, ma'am. I request Banu, ma'am, to give vote of thanks.
Thank you very much, ma'am, for your enlightening and thought-provoking session. Your words have truly added immense value to our faculty development program. On behalf of the organizing team and all the participants, I extend our heartfelt gratitude for sparing your valuable time with us today and sharing your knowledge, insights, and experience. Thank you, ma'am.
Thank you very much.
Thank you, ma'am, for your inspiring speech.
Participants are requested to fill your feedback, which is posted on chat.
Ma'am, feedback link is not there, ma'am.
Wait, ma'am, we will post it. I kindly
Now you
request
can
all
see,
our
ma'am.
participants to stay in the line. Session 2 is going to start soon. I ask the participants to stay in the line. We will be going to